Okay, let's unpack this. I mean, if you're involved in, say, large-scale video monitoring or security, you know the core conflict, right?
Oh, absolutely. It's this huge question. Do you spend a fortune replacing miles of old coaxial cable?
Just to run these modern but sometimes lag-prone IP systems?
Or do you stick with the obsolete low-resolution analog? It's a real industry-wide headache.
And that's our mission for this deep dive. We're looking at the engineering that solves that. It's called High Definition Transport Video Interface, or HDTVI.
Right, and specifically the hardware that lets it leap onto fiber. We're talking about the Thor Broadcast F-4HD extender.
So what's the big idea here?
What's fascinating is that instead of forcing you into this massive, costly overhaul, the tech acts as a really pragmatic bridge. HDTVI is, at its core, a digital signal that's cleverly modulated onto the old analog baseband video.
So that digital to analog modulation,
Yeah.
that's the key. How does that physically translate to, cost savings for someone looking to upgrade?
It's pure CapEx savings. The game-changing advantage is that HDTVI supports true 1080p high resolution.
While reusing the exact same coaxial cables that were put in for old analog CCTV?
The very same ones. You leverage the copper wiring you already own.
Yeah.
It slashes labor costs and downtime.
Okay, so that's the genius of HDTVI on copper. Now let's talk about the hardware that makes that signal jump even further onto fiber optics. This extender, it takes 4 channels of that signal.
And it's compatible with similar standards too, like HDCVI and AHD, all up to 1080p.
And it converts them into what? Modulated light.
Exactly. And that conversion, that's where you unleash just massive distance capabilities. This is where the physics of light really start to matter.
So how far are we talking?
Over single-mode fiber, we are extending signals up to 20 kilometers.
20 kilometers, wow. That's
Wow.
like monitoring an entire port facility from one central point.
It is. And even with less expensive multi-mode fiber, you're still getting 2,000 feet.
I see our source material mentions this system uses 10-bit digital video encoding and uncompressed transmission tech called Green Craft. Why should you care about those acronyms?
Well, CRFT means the signal is truly uncompressed. It's lossless. That is vital.
Because compression artifacts over 20 kilometers would make the footage useless for, say, security.
It would be a blurry mess. And 10-bit encoding isn't just a number. It translates to a much wider color gamut, better detail and tricky light. A huge step up from older 8-bit analog systems.
And beyond the video itself, it says here the system is plug and play. No frustrating adjustments. But what about control? I see it mentions one channel of reverse RS-485 data.
That control channel is a key differentiator, especially when we get into the great video standard showdown. RS-485 lets the operator, who could be 20 kilometers away, instantly pan, tilt, and zoom the camera.
Without needing any separate cables or equipment.
Not at all. It's built right in.
So that brings us to the comparisons. If HDTVI is so powerful, there must be a trade-off. Why isn't everyone just ripping out their IP systems?
IP cameras have their place, for sure. Great networking flexibility. But they have 2 big problems. One is latency.
About a delay.
A noticeable one, yes. HDTVI has virtually no transmission delay. In surveillance, 0 latency is paramount for real-time reactions.
And the second problem?
Distance. HDTVI can cover 500 meters on coax, no booster needed. An IP camera chokes out at 100 meters on standard Ethernet.
Okay, and what about compared to HDSDI? That's another HD standard over coax.
HDSDI gets completely outmatched on range. It struggles beyond 150 meters, so HDTVI more than triples that. And remember that built-in RS-485 control.
Right.
With HDSDI, you need entirely separate additional equipment to get that remote camera control.
So the bottom line of this deep dive is that HDTVI offers this excellent cost performance. You get much higher resolution than old analog.
And it just cleverly gets around the distance limits of standards like HDSDI while completely avoiding the latency problems you see in IP systems.
A way to get high-def, high-reliability video over long distances using wire you already own, and then extend it even further over fiber.
Exactly. This device really capitalizes on the fact that sometimes the future isn't about, completely replacing the past, but about clever modulation. So here's a thought for you to explore.
Go on.
What other legacy infrastructure are we all using right now, be it old phone lines or familiar coaxial cable runs that could be secretly hiding a high-definition future, just waiting for the right device to unlock it?